Our mentor for the day is J. Timothy Lincoln, PE. Mr. Lincoln graduated with a Bachelor's of Civil Engineering from Auburn University in Auburn, Alabama in 1979. His primary interest was studying in hydraulics. He attended graduate school at Auburn with a focus on environmental engineering. Prior to joining the City of Houston in 1981, he worked as a soils and concrete lab technician of Alabama Power Company at the Miller Steam Plant construction site. During his employment with the City of Houston, Mr. Lincoln has worked as a design engineer for water distribution and capital projects planning and water engineering for the Department of Public Works and Engineering. He received his professional engineering license from the state of Texas in 1991. In 1997, he began working in the construction branch of Public Works, first as a project manager and finally as a senior assistant director for all infrastructure being constructed by the department. This program totaled $350 million to $450 million per year, with about $1.1 billion on the books for any given year. In 2012, Mr. Lincoln became the city engineer for the Department of Public Works and Engineering. The Office of City Engineer is the chief regulatory office for all matters within the public right-of-way. This includes, but is not limited to, water, sanitary sewers, stormwater pollution prevention mechanisms, electric, fiber optics, and natural gas. Accompanying Mr. Lincoln is Ms. Megan Jordan, a native Houstonian. Ms. Jordan graduated in May 2015 with the University of Texas with a degree in civil engineering. While still in school, Megan discovered her desire to serve the public through engineering while interning with the Texas Commission of Environmental Quality. She continues that service today as a graduate engineer with the Office of the City's Engineer's Stormwater Section. When she isn't focusing on street flooding, you can find her training her dog to wear shoes. Please welcome Mr. Tim Lincoln and Ms. Megan Jordan.
Some things don't change. Everybody always likes to sit in the back of the class, right? My name is Tim Lincoln, and I am the city engineer for the city of Houston. We have just a short PowerPoint presentation, and then we'll take some questions about what it means or what we do as engineers that work for the city government. And there's some parallels with that with the private industry. There's one big difference though. If you can hit the next one. So what is engineering? It's what that is right there. I mean, y'all can read this yourself, but it is the application of mathematics and empirical evidence, which is our empirical evidence of scientific, economic, and social and practical knowledge. It's what, as a whole person, as a whole entity, that we do to make life better for those people that are around us. If you go to the next slide. So what engineers do to work for the city? We do planning, we do design, we do construction, we operate, we maintain, and that in every engineering field, whether it's public or private, does those first five things. The things that makes us different is we also regulate. That's what we do. Mainly what we do is to make sure that things that are constructed in the city of Houston, whether on public property or private property, can be operated, maintained to a level to where if you have to maintain it, you don't have to go out and get some exotic piece to make something work. All of our fire hydrants are exactly alike. You can take one fire hydrant piece, take something out of that fire hydrant, put another fire hydrant that works. All of our water mains are exactly alike. We have these standards that we use in order to have an orderly operation and maintenance of our systems. So planning, it is probably the most important, because if you cannot plan, you cannot build. So what do we do? We evaluate the existing conditions of the roads. We have a truck that we spend $500,000 for that goes around the city every 2 years on every street in the city, and it's got these computer gadgets, and it's got these other gauges on it that will tell you, it videotapes it, and it just travels down the road. And it will tell you how bumpy the road is, what the design of the road is. It'll tell you what it's made out of. It gives you all these parameters, and then that's downloaded into a big computer program, and it can actually rank the roads of whether how good or how bad they are. that's how we do our planning in order to, one, rebuild roads or to maintain the roads. One of the things, you ever seen these big stinky asphalt machines that lay asphalt? That is not new construction. That is a form of maintenance for the roads of the city of Houston. We also do the other part of it is to evaluate the growth and determine the needs to save the health and safety of the citizens. When I first came to the city in 1981, which is a very long time ago, we had a project that was in the planning stage called Keegan's Bayou. Keegan's Bayou is about 80 miles or 70 miles to the east of Houston. They have this past 2 years, they have started constructing it, and that is where we're going to get our water from. Right now, we get our water from Lake Houston. We get it from the Trinity River. We get it from Lake Conroe. We get it from Lake Livingston. We also get it from groundwater. Now, because of future growth, because they're expecting that Houston will double in size in another 20 years, we need that water. So we're going further east to get the water. Some of it may be officially coming from the Sabine River, which is, is on the Louisiana, Texas border. So it's a good long ways away. But that's something very far in the future. But right now, Keegan's Bayou is where the new source of water will be coming from. But just think, we thought about that 30 years ago. And now it's coming into fruition so that we can tap that water and bring it in so that people can drink. But if you look at it, it also includes roads and bridges and traffic control devices. Traffic control devices are a bunch of different things. There's signs, there's signals, there are the bumps in the road, or what we call traffic cushions, if you see those down, the little rubbery things that are in the roads. The storm sewers, storm detention. Any of y'all lived here, I'm assuming your whole life, you know it floods here. One of the things that we've really instituted in the last 20 years is to make storm water detention. Detention means to temporarily hold. Retention means to hold permanently. So what happens is when it rains and all the rain starts, with all the buildings and stuff, that water's got to go somewhere. Well, we don't want it to go in the roads. We don't want it to go in people's homes. And so we channelize it to go in these big ponds. And then with these big ponds, it will temporarily hold the water so that when it quits raining, the water will drain out after it quits raining to hopefully alleviate some of the flooding. And then there's water mains, which is where I worked for most of my career, or a lot of my career. Water treatment, water supply, which I just talked about. Wastewater line, lift station, wastewater treatment plants. And it's kind of interesting. When I was in graduate school, I took environmental engineering, and my interest was in wastewater treatment plants. It sounds kind of icky, but it's actually a really cool process of how you treat wastewater. So, and you take this part because this is what you do. You help in design and regulate.
Yeah, so I help in the design phase of regulation. So I'm a graduate engineer, which means that every day I get 10 to 20 plan sets on my desk of things that are proposed in the right of way across the city of Houston. And it could be the water main, storm sewer system, it could be a sign for parking, anything that goes in, we do review. That's an example of it. I actually pulled that from a 1981 drawing, so kind of cool, pretty old. 1981.
Yeah, it's old.
That wasn't mine.
Well, yeah, I'm sure deputy.
So I get the plans in and I review storm sewer. So specifically, I look to make sure that the existing or proposed storm sewer system is not going to have any adverse effects on street flooding, adjacent properties. We have a design manual called the Infrastructure Design Manual that Mr. Lincoln helps write himself. And I review from those tenants. Chapter 9, stormwater, I'm in there all day.
And she did say something right there. We have a thing called the Infrastructure Design Manual. And that gets down to the neat and orderly way that we construct things. Any engineer that does business with the city of Houston must use this manual. Now, I will tell you, this manual, she says, I helped write it. All I do is organize it. We have a group of people that is internal to us. The engineers out in the real world that are civil engineers or electrical engineers or mechanical engineers that work for developers, that work as engineering consultants, and the people that we build these things for, we sit around for months and talk about the infrastructure design and how it can be improved to make it more worthy of the innovations that we use today. The part of this I want to say is, as an engineer, you do not work in a vacuum. You're not going to be sitting over in some corner your whole career engineering. There's a lot of social interaction in engineering, and it gets down to no matter what kind of engineering you do, it's about health and safety to the public, or health and safety to those people that you work for. So, I guess we're going to move on after design. We're going to have what? Build, construction. This is the other thing I did. I became a civil engineer because I thought playing in the dirt would be fun. And to be honest with you, it is fun. There's some heartaches, headaches that go around with it, but in the city of Houston, our construction people, we don't actually run the backhoes or anything to go out there and dig up the dirt and put in the new utilities, but we do manage that. We use Microsoft Schedule to look at how things are predicted to go along as opposed to how they are going along. We provide the inspection services, which is we make sure that look in the hole, or we watch the contractor and make sure he's doing the things that are in that infrastructure design manual and in our standard specifications. We make sure that he does his job right. And also that we interact, there goes the social aspect of it again, that we interact with those people that are affected by our work. One of the things that if you've ever, and there's a lot of work being done right here, Belleville Boulevard is a perfect example. Took a long time to build that. There was a lot of frustration involved with it. But one of the things that people need to realize, if we could have shut that road down, just shut it down, and gone in there and done everything at once, it would have taken about 1/3 of the time. But you can't do that. You gotta have, people gotta get in and out of these businesses. We can't adversely impact the businesses any more than we have to. So by having these staged construction sites, construction phases, it allows people to come and go to these businesses or school or whatever while we're constructing the road. And it is frustrating to everybody, but it really beats the alternative of not having access to it at all. So construction was a pretty cool thing for me. And then we get into operate. This is one of my things I've always asked, and you hear this for the first time, but as designers, I really believe that if you're going to design something, you need to go out and see what you design. You need to go out, if you're going to be an engineer and you're going to be designing things, you really need to go out and look and see what you designed, how they built it, how they operate it. Because you can design anything, but if you can't build it, operate it, or maintain it, it's useless. It'll serve a purpose for 2 years instead of 30 years. So, operations, we do have engineers that do that operate. We have also chemists, chemical engineers, mechanical engineers, electrical engineers. Most of these people work in, that is the Southeast plant?
Yes.
Sims Bayou, that's the Southwest, the South wastewater treatment plant. That's pretty cool. I don't know if you can see it, but I was involved in a project, and you can. One of the things that you do in the wastewater treatment plant is you oxygenate, blow air into these big tanks to activate the bacteria to eat the dirty water. And there's a blower building in there that has blower pipes big enough you can drive a car through. So just think about how much air that's flowing through and how big that plant is and how much wastewater it does treat. And then we get down to maintaining, that's the other part. It is for safe operating conditions. They do small scale, extends the life service, maintenance. You take your car in to change your oil, right? Or your parents do, take your car in to change your oil. That is a form of maintenance. You can drive the car without changing the oil. It will work, but at some point, that car is going to break down. We do the same thing to our systems. Our systems, we maintain them in order to extend the service life of them. The other thing to maintain is we improve conditions before and after inclement weather. People in Florida, you have the evacuation. Well, there's a lot of people that aren't evacuation, and a lot of those are public servants. Those public servants are battening down the hatches right now in Florida to make sure that the wastewater treatment plants are not adversely impacted, that if a storm surge happens, they're going to minimize the amount of water, of dirty water that's going to go out of that and create an environmental problem. They're going to have people on staff at their water plants to make sure as soon as the storm's over that they can get that water up and running again. So a lot of this has to do with improving conditions between before and after inclement weather, and also to maintain the health and safety. And then the last one, I think, is to regulate. And that's what a lot of what we do is. We make sure that people design and build things that are to a standard that does not impact your health and safety, that it can be maintained. There's a lot of different agencies. She has a few here. Except not us. Why are we in there? Oh, okay. Well, anyway, we're not in there, but that's what we do. But we ensure the health and safety, we create revised standards, and then we also approve construction of public and private infrastructure provided by developers. There's one thing that I hope y'all saw in every one of these things, and that in every aspect of what we do as engineers, it involves health and safety. That is if you want to tell you what engineers do, they innovate, they invent, they make things better, but there's not an engineer around that's ethical, that's going to invent something that's going to make your life worse. It's always going to make it better. Go ahead. So, we are civil engineers. Any form of engineering, whether it's electrical, mechanical, chemical, there's a whole bunch of different types of engineers. There's subgroups of types of engineering practices that are within that broad spectrum of electrical engineer or civil engineering. And in civil engineering, there's basically 6 of them. One is environmental, and that is, it speaks for itself. It's about wastewater treatment plants. It's like cleaning up landfills. It's to make the world around us a little cleaner, a little safer. There's structural, which is these buildings, bridges. That's structural engineering. There's geotechnical, which is, there's actually a lot of different subgroups. Geotechnical, there's like skin, friction. If you're going to build a bridge and you're going to put a column in, well, that column below the dirt is designed. And the way it's designed is this thing called skin friction. And what it does is that you got the column, you got the earth, and it rubs back and forth like that. Well, that skin friction, you want that column deep enough that it won't move anymore because that dirt around it will hold it in place. Traffic and transportation has anything to do with geometrics, designing roads, making sure like if you're on a highway, if you've ever been in a highway, parents driving, you're going 70 miles an hour, and all of a sudden the turn is too tight. Well, that's just bad engineering. That turn is supposed to be wide sweeping so that you don't feel the G-forces kicking you out and could cause an accident. It also has to do with what we call traffic impact analysis. This is one that greatly affects the people of the city of Houston, and it's all the traffic out here. Believe it or not, it could get worse. We try to do things like putting in turning lanes or putting in traffic signals, how they're timed, to try to lessen the impact of all those people. Because just like the water resources, in order to build up for the future growth of the city to have that water available, it's the same thing with the roads. We have to plan that. And to be honest with you, it's harder to plan for roads, traffic growth, than it is for water growth. Because of traffic growth, you're limited in your space. We can go out and buy property, but it becomes it's not cost effective. So we have to find other ways to do it. There's water resources or water resource, that's hydrology, which is the flow of water above or in the ground, or hydraulics, which is the flow, which is what I really did in college, which is the flow of water in either pressurized systems like water mains, or in closed systems like a storm sewer, or an open ditch system, which is a open channel flow. It was pretty cool. As a matter of fact, if Alan, I just emailed him a little video.
It's the last icon on the
Okay,
cast
well,
bar.
cool. We'll show that in a second. It's really cool. It's a hydraulic jump is the first one that you see, and it's really a cool looking thing. And then there's construction planning and management, which is kind of self-explanatory. You know, we manage construction. And so, is this the last one? I think it is. Through the years of working for the city, sitting around talking to other engineers, we started talking about things of what we wished we knew before we got into engineering. What are the things, what kind of classes when we were in engineering school that we wished we took, something that we missed out on? And I came up with these 4 types, because you will take technical writing. Did you take technical writing?
Yeah.
Okay. You will take technical writing, supposedly, maybe. But those are the 4 things that I wished, and I took actually one of those classes, but creative writing. If you cannot communicate, you cannot do engineering. And creative writing is the best way in order to communicate with people that are not engineers. One of the things that we're accused of, and rightfully so, is that no matter what field you ever go in your life, you're going to have an in lingo. You're going to be using words that only you and your peers will know what it means. Well, we go out into the public and we start using our in lingo, and they don't know what we're talking about. So by creative writing, we can explain better what's actually going on, which kind of dives into the communication. I did take a couple of communication courses in college, which is really kind of cool. Social interaction, I have that. That's just kind of a personal idea. Again, if you think you're going to be on a corner just doing engineering, you're dead wrong. Everybody collaborates. It's necessary. Even if you're doing research and development. Research and development is kind of like over in that corner, kind of thinking things up, but you still got to collaborate with people. And then the other part of it is business operations and financial. When I got into management, I knew nothing about business operations and financial. What I knew about personal budgets, but I didn't know how to do a work budget for a section. So those 4 things are things that y'all need to think about when you're in college if you go into engineering, because you are going to take electives. One thing in college, you think you're going to take nothing but engineering courses in college, you're wrong. College is more than just engineering, it's more than just science. It is a social construct, and you have to take certain prereqs, and you have to take other electives, and the electives you take can benefit you greatly when you're in college. The other thing I'd just like to say is when I graduated from college, the day before I graduated, we had a senior meeting with our department head. And this was a long time ago, and it's something that's always stuck with me. He told us that tomorrow when you walk down there and you receive your diploma, understand once you walk off that stage is when your real education begins. All we did was teach you how to think. And it stuck with me, and it's true. All they did was teach us how to think. It gave us the tools to think, but the education starts when you leave and start going into the workforce and trying to make your way through the world. Would you like to add anything there, Megan, of any insight of what engineering school is like today? Because I don't know.
Maybe a piece of advice I would give to engineers entering school. Most of you are probably perfectionists. I definitely was in high school. Straight A's, got to be on a test, kill me for days. when you get into engineering school, you can't be perfect all the time. And I know a lot of people who got discouraged and dropped out because they weren't making straight A's, they weren't doing as well as they thought that they should have. It's something that you need to stick with. It's definitely a process. Find a good group of friends to study with. Study with the same group of people for 3 years. Find your niche, put your nose to the grindstone, and do it.
So, where's that little icon with the? So you gotta go to the main screen?
Yeah, and the farthest to the right on the task.
Oh, is that right?
It should be the video. There you go.
Okay, so I was on Imager the other day and they had this. Yeah, okay. Somebody giggled. They had this video, and I hope it loops. This is what I practiced in school. That is a dam that's releasing water. That first part is called a hydraulic jump. And basically, it doesn't have a stilling basin. Again, I'm talking in lingo. But a hydraulic jump is nothing that the water's going so fast and has so much kinetic energy, it actually jumps up to store energy as potential energy. It's called a hydraulic jump. Now, there's something downstream that always stops it. But it's really kind of cool to see a stabilized hydraulic jump. This just shows you a little bit about what civil engineering and the power behind it does. This is all water being released from dams. But it's really cool. If you've ever been around anything like this, the sound is deafening. It is loud. So I just wanted to show just a little video. Yes, ma'am.
When do you have to release the water?
I'm sorry?
When do you have to release the water? Like, I know this isn't like occasional. Is it like, what kind of circumstances?
Well, it would be a lot of different reasons, of course, if you have a lot of rainfall. It would be if they're generating electricity. It would be when they're performing maintenance, because you always, that's that part about maintenance. They have to maintain these dams. Or for that one, they may have just been doing it for show, for all I know. But those are the three biggest reasons. And you gotta, the other thing that people think that dams are there for flood control. Dams, typically, there's not very many dams, especially in the state of Texas. I don't know of a dam in the state of Texas is for flood control. They're all for storing water for drinking water. They're reservoirs. Lake Mead, which is, I guess one of those was from Lake Mead, that is drinking water and hydroelectricity. But Lake Livingston Dam, Lake Conroe Dam, that's nothing more than just storing water so that when we have a drought, we have water that we can use. One of the things that happened back in 1994 is there was a big flood. It's called the day the San River caught on fire because it knocked a lot of gas lines out and the river actually caught on fire. But on Lake Houston, water was actually 9 feet above the dam going over. It's never seen it before, 9 feet. Water this big for a mile and a half, because the dam is a mile and a half long, going over that dam. That's how much water was there. And people were upset because it was causing flooding. Well, Lake Houston's it wasn't meant to hold back water for flooding. It's not its purpose. But it was, what it did afterwards, you're talking about that being a hydraulic jump, there's these things called stilling basins, which is just like a big concrete channel. It's got a bunch of knobs in it. And what it does is it takes that kinetic energy from the water flowing and it hits these nubs and it breaks it up and it causes a lot of turbulence and chaos. What that does is it takes the energy out of that water so it doesn't eat things downstream. Well, there was so much water going over Lake Houston Dam that it tore those knobs out, it's called a stilling basin, tore it up, went downstream and gouged out a 40-foot hole that was a half a mile long. And it undermined a lot of the river, and it cost us millions of dollars to fix that. It was, I got the opportunity to be on that project. It was really, really a cool, well, frightening to see what water can do. But I don't know if y'all have ever heard of this. 6 inches of water rushing past you can kill you. It will knock you down and kill you. 6 inches of water can knock you down. You cannot stand up in 6 inches of rushing water. Now, it has to be going pretty fast, don't get me wrong. But it's water's something that's not to be messed with very often. Anything else? Couple
Any innovations coming to the city that you're interested in or excited about? Anything?
Yeah, well, we're getting these new programs that are models, that model, each time they come out, they're a little bit more, gets a little bit better into the real world. We have models now for our storm sewer systems that we can predict what happens and pretty accurately what happens under certain conditions. The interesting thing about living down here is we get a lot of rain, but it can rain, and I know this for a fact because we got sued over it. It rained 9 inches over at West Bell and Memorial, and it was sunshining downtown. 9 inches in an hour and a half. So, what other innovations? We have what's called the electronic plan review. It's been online now for almost a year. It's where we review plans, or you submit plans, it's always paper, right? It's paper. But now we can do it electronically, and we can communicate electronically. So that's pretty interesting.
When you have projects, when you're like building, like making maybe a new road or something, does the government have like their own construction company, or do they like, depending on the type of construction, do they like find a third party? Like
That's what we do. You're exactly right. We third party 99% of what we do about it. We just don't have the capability. These companies, if you think about it, $400 million worth of work in 1 year, that would take a lot of construction people. So we farm it out, we bid it out, and we do have private companies construct them for us. And it's the best way to do it. Oh, the other thing we have is we're going to double the capacity of our Northeast water plant, and we're using a little bit more innovative technique of how to manage and construct it. As a matter of fact, what's going to happen, the way you usually do it, you design plans, you throw them out there to be bid, the guy gets the bid, and then you construct it. Well, now we're building it as we're designing it. We have it planned out, but it's called construction manager at risk. But as we're designing the plant, we're actually constructing it, which it moves it along a lot quicker and faster and more efficient, to be honest with you. And because we are a government, it took the state legislature about 5 or 6 years ago to allow us to do things like that. The private industry's been doing it for a long time. So there had to be a change in state law in order to do it. It had been 10 years ago. Time flies when you have fun. Anything else? Yes, sir.
If there isn't any big projects going on currently, where does most of your time go into?
My time?
Or just the time in general?
The big project we have now is a Northeast plant, and we have a management team up there of about 15 people, and they monitor what the guy does. They make changes. My big thing is that one of my main jobs is that I do what's called dispute resolution. If I have, I was thinking about this last night. You read Charles Dickens, and you have to give a book report on it. Well, you don't give a book report on what happened. You give a book report sometimes on your interpretation of what happened. What does it really mean? How does it fit a bigger picture? What was he trying to say? Unfortunately, specifications are the same way. We write them, this guy reads them, and he's saying, well, I understand this to be something else than what you meant. So what I do is I get the parties together, and I do a dispute resolution with them and make a ruling on what those specs really mean. Who's right and who's wrong. And it's kind of interesting because I work for the city. You would think, a lot of people think that I always rule in favor of the city. Well, I don't. 70% of the time I rule in favor of the contractor because we wrote the specs very poorly. So that's one of the biggest things I do. But a lot of the projects, it's just getting understanding the plans, understanding the specifications, understanding what we're trying to do, understanding that the contractor, you want the contractor to be on line with you on, make sure that y'all are going in the same direction, and sometimes it works and sometimes it doesn't. But most of it is interpreting specifications and that social interaction again. I just can't bring that up enough. I'm sorry. I mean, it may sound like a broken record, but the interaction that you have with other people is so important. I mean, it's really important. It's like, I told my son one time, you gotta communicate. It's like two guys digging a ditch. They have to communicate, because if they don't, one guy in the lead's going to be taking that dirt, he's going to be throwing it over his back, and he's going to be hitting the guy behind him, and that guy's got to sit there and dig that and throw it out. Well, if they're working together and they're communicating, they're going to go twice as fast, because he's not going to be hitting the guy behind him with the shovel of dirt. So communication is a big thing. Kind of got off on a tangent there, but excuse me. Anything else? Yes?
So the work you do, is it just like from like things the city gives you, and then like you like build on it and then like oversee it?
Yes. That's pretty much it. Certain sections of the city, that's exactly what it is. We regulate, which means they give us things, we look at it, and we say, yes, that's right, no, that's wrong, or yes, you need to add on to this. Another group within the Public Works is called Engineering Construction Division. They get a thing called a preliminary engineering report, and they read it and they say, that looks great, but you need to add A, B, C, D. We need to expand this out. We need to make this street wider. So yes, that's exactly what we do. We take what other people give us and expand on it.
So how does Houston not having major zoning laws affect you guys compared to other major cities?
I'm sorry?
So how does Houston not having major zoning areas like industrial, residential?
Oh,
affect you guys
because
compared
that's
to-
what the people of this great city
Well,
voted for
oh,
a
yeah,
long time
absolutely.
ago.
But my question is, how does it have changed what you guys do compared to other
Oh,
cities?
it's very, yeah. The city of Houston has no zoning. I've been heard that we have de facto zoning by ordinances. I could put a chicken barn, or not a chicken barn, I could put a chicken processing plant in the Heights. There was one there 5 years ago, which is not a real cool thing to have, but we also have laws on the books that says you can and can't do certain things. Actually, not having zoning has really impacted the laissez-faire type attitude and growth of the city, and it makes it a very vibrant city. I'm kind of stuck between zoning and no zoning, but I kind of prefer the no zoning because it does give the city an opportunity to do things that other cities cannot do. But it does impact us a lot. And you do have, somebody will build a $4 million house right next to a woodworking shop, which if you're in the Heights, you see that a lot. Yes, ma'am.
This is a question for her.
Okay. Her is Megan.
I'm so sorry.
Oh, it's no problem.
When you were in college, did you plan to go into civil engineering? And when you got out of college, was it really easy for you to find a job, like a really good job?
When I went into college, I knew I wanted to go into civil engineering. I decided that probably around your age somewhere. I knew I liked math, I knew I liked science, but I didn't want to be a pure mathematician or a scientist. Engineering gave me a way of having a field I could go into, interact with the public, and have something useful, something I could go out and see in the world. But so I went in knowing I wanted to go into civil engineering. What was the second part? Job. I had an internship throughout college with the Texas Commission on Environmental Quality. I would recommend all of you get internships, several of them in college, that will help you when you find careers later on. I graduated in May. I interviewed with the city August after I graduated, and I started with the city almost a year ago in November 2015. So it took from graduation to starting probably about 6 months. But I had friends who had jobs lined up before we graduated, so it really varies. And I have some who didn't go into engineering. I have a friend in the Peace Corps, I have a friend in law school, all engineering degrees. So options are unlimited.
And the delay to hiring her had nothing to do with her, it has to do with us. We're a bureaucracy and it takes time.
Yeah.
You have another question, don't you?
This really
That's good, I like it.
It's because I'm really just like being an engineer and stuff. How would you say like how much do you like actually go outside and like look at everything and like you know like? I just
Can I answer
don't-
that question?
I can't think of like
Not
sitting
enough,
all
not
day
enough.
long, you know? I can't
She
think-
can answer the rest of it, but I'm gonna say not enough, but go ahead and answer it.
Working for the city, I really don't have as much experience in the field as some of my friends in the private industry have. So yeah, still want to go out and see a panel.
You know what? I think that you asked a very good question. It's gonna cause a change in our office. Because that's one thing that you need to see. You need to see what we're approving, what it looks like, because it's different.
How much do you go out? You go like every day, or is it just like well?
I used to go out every day. I just sit in an office now. No, I go out, if I usually go out on my way home from work, I'll drive by someplace and take a look at it. If I get called out, it's because of a complaint. But that's just because of my position. But when I was in construction and I was in design, I would visit my projects once a month. So I'd probably be out about 7 or 8 days out of a month. When I was in construction, I was out a lot. And that's why I do believe that you really need to see what you approve or what you design, because it takes a lot more room to put in a manhole than people think it does. It takes a lot more room to tap a water line to put in a meter than people really think, because you just got this little bitty tap. I mean, it's this big, you know, but you gotta dig a hole this big in order to make it safe, in order to tap it. And people don't realize that. It takes a lot of room to construct things. I guess, how many were out here when they were rebuilding Bel Air? So you know what it looked like. It was a mess. So yeah, it just takes a lot of room. But yeah, you need to go out and play in the dirt. Yes, ma'am.
When you were doing like designing and building at the same time, would you go out and decide like you wanted to change this and then like give it to the builders to like change what they were
No.
doing?
The answer is no. That doesn't mean it didn't happen. I would get called out a lot because what we had on paper didn't match what was out in the field. And so yes, we would have to make changes. But the way our contracts are written, you really don't want to do that a whole lot, because that creates what's called a change order. A change order is something that happens that's going to cost the citizens, the city, time and money to pay that contractor to do something different. So you try to minimize that as much as you can. But yes, we do it. I mean, you know, gotta be out there digging, and all of a sudden you get this big line this big that nobody knew was there. So you have to do something different. So yeah, but you don't want to.
And the way you were designing it, did you do like you like built the structure and then like worked in, or was it like?
I'm sorry, say that again?
Like how did you like design it while you were building it? Did you work like on the structure? And,
Oh, the
like,
design build? I'm not actually doing that. They're doing that out there. Because they have a plan. They know what they want. You know, they have a good idea about the processes that it's going to take to build this plant and where these items and these processes are going to go. So what they do is they do what's called civil site work, which is do the paving and the drainage and get the site ready. And then they start building the clarifiers or building other parts of the building. They just don't have it completely designed yet. They take care of the big things, and then as the project moves along, they start getting more in depth and deeper in detail in it. Now, the thing is, these people have done this a lot, so they already know how it's going to go. You know, the contractors and the engineers, they build water plants. That's what they do for their living. So they've done it for years, so they know how it's going to go. So what we do is use this construction management and risk and utilize their expertise in order to move the project along faster. Would be a good way to do it. I'm trying to think of something that trying to like rebuilding a car engine or something like that. I can't think of a good analogy, but it's pretty interesting the way it works. It's completely different. I mean, you have to be really engaged in what you're doing. It's really cool. So yeah, oh, come on. Got one more question?
Are there any misconceptions you think that the public have about what the city does as engineers? I mean, you get a lot of, when everything goes wrong, people blame, but is there anything like?
Go ahead. You're new, so I've got 30-something years of misconceptions.
I feel like the largest misconception, I'm on the front line, so I meet with the public pretty frequently, but I feel like the largest misconception is that we don't know what we're doing, things move slower in the city, that we're less open to change or innovative ideas, which I don't believe is true.
There's a level of truth to that, there is. That's one of the things I try to affect is change, and I lose a lot. Sometimes I win, sometimes I lose. What is the biggest misconception? I think that the fact that we're shovel leaners and we don't know what we're doing is probably a big misconception because we're government workers. I've been told many times that somebody could do my job 10 times better than me in half the time, and all I could tell them is, you know what? Come on over, you'll last a day. Because we put up with a lot. Working for the government is completely different than working for private industry. We are transparent. That means, it doesn't mean we have all our secrets out there, because we don't really have that many secrets, but we operate under a different set of rules, completely different set of rules. And because of that transparency, that it creates a bureaucracy, because you got to sit there and demonstrate everything. It creates a bureaucracy that does slow us down, but it's necessary because y'all pay our salaries. In private industry, you don't have that. You can keep secrets. You can do things without having the public, engaged on you. And the other one is, a lot of people think they own us. That's kind of one of my biggest pet peeves. The other thing is, I tell you what we do a lot of, especially in our office, and you may get to experience this one day, is that we play referee between two neighbors that have disputes with each other. And that's sad. Really, two neighbors that don't like each other, so they call, instead of calling the cops, they call us because they find out that they think that something's illegal that they did, and it turns out that they didn't do anything illegal, they just did something that they didn't like. So that's a common misconception. I like people like Megan because she's from the outside. She brings in new blood. She's not jaded because there's a different level of jadedness that happens. You may want to turn that off. No, I'm just kidding. I like the idea of bringing young people or even older people that are from the outside in because they have a different experience, because no matter what we do, we tend to get in a rut sometimes, and I'd rather have people around me that'll tell me I'm wrong, that there's a different way to do it that's better and cheaper and better and faster and all that is good things, because I will listen, than have somebody that's been there as long as I have. I mean, I've been there a long time. It's about time for me to go to the pasture, because it does need new blood. I think that it's important that people that have new ideas come in. Now, I've only been in this position for 4 years, so I've had new ideas. But a lot of it is also the social interaction, trying to motivate people to do things for the right reason. One of the things I have on my wall is, I have these little things, you know, good stewardship, being timely, teamwork. One of the things I have on my wall is defend your decisions. Because if you make a decision and you can't defend it, then it's not a good decision. And I want people to be able to defend their decisions. Because the other part to that is, I can back you up if you can convince me that your decision is true and correct. Yes?
On city projects, do you have a time limit of like how long they'll give you to like get it done?
Yes. From the planning part to all the way to the design and putting in the construction, every one of those has a time limit. The planning part, we give a year for the design. It depends on how big the project is. It could be anywhere from 180 days to 2 years or 3 years to design it, depending on how big the project is. And there's penalties if they don't do it right. Then on the construction side, every one of our construction jobs, do have a number of contract days. And for each and every day that they go past that, they are assessed what's called a liquidated damage. A liquidated damage is not a fine. It's not something, a penalty at all. All it is that we've determined that it costs the city of Houston, let's say $1,200 a day to have this project open per day. So any day that goes past that, we're going to recoup our own money. And that's called liquidated damage. So yes, everything that we have has a timeline. Everything. That's a good question. It seems like it's forever, doesn't it? I think they had like 540 days to do this project down here. That's calendar days, you know. And he went over about 100 days. Anything else? All right. Well, thank you very much for inviting us. Y'all really need to talk to Megan too. She has more direct knowledge of how it's going to impact you if you depend on going to engineering than I ever would, because the schooling is a lot more recent, and she can tell you more about the college experience. So, but thank you very much.